Day 531 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2598, smallest missing non-negative integer after operations. The difficulty level is medium, but you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a zero index integer array nums and an integer value. In one operation, you can add or subtract value from any element of nums. For example, if nums is an array of integers 1, 2, 3, and value is 2, you can choose to subtract value from nums of 0 to make nums equal to negative 1, 2, 3. The max minimum excluded of an array is the smallest missing non-negative integer in it. For example, the max of an array of integers, excuse me, y'all, negative 1, 2, and 3 is 0, while the max of an array of integers 1, 0, and 3 is 2. Return the maximum max of nums after applying the mentioned operation any number of times. All right, y'all, so that sounds simple enough, but let's take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 1, negative 10, 7, 13, 6, and 8. Value is 5. Our output is 4. The explanation says one can achieve this result by applying the following operations. Add value to nums of 1 twice to make nums of 1 equal to 0. So we're going to take this 5 and add it here twice. We're going to add it right here twice, and now that becomes 0. Boom. Then we're going to subtract the value from nums of 2 once to make nums of 1. So we're going to make this 7 into a 2. Boom, just like it is here. This is what the array would look like. Then we're going to subtract the value from nums of 3 twice to make nums of 3 equal to 3. Boom. So that would be this right here. We're going to subtract 5 from 13 twice, which is going to leave us with 3. So this will be the final array. And when this is the final array, the max of nums is 4. It can be shown that 4 is the maximum max we can achieve. So you can see from this case, the missing number, we have 0, then we have 1, 2, 3, then we're missing 4, 5, and 7. Now the max is the smallest missing negative number, right? So the minimum excluded number. So the minimum excluded number in this case would be 4, even though 5 and 7 are missing as well. 4 is the minimum, so we return 4. So just in case that didn't make sense to y'all, let's take a look at example 2. So in example 2, we have our input nums equals an array of integers 1, negative 10, 7, 13, 6, and 8. This time value is 7, and the output is 2. Explanation says one can achieve this result by applying the following operations. Subtract the value from nums of 2 once to make nums equal to, so we're going to subtract 7. Value is 7, so we're going to subtract 7 from this 7, and that's going to make it 0. Boom. Once we do that, the max of nums is 2. It can be shown that 2 is the maximum max we can achieve. So once we subtract this and we make this 0, then we have a 0, or let's look at this array because it's already done for us. So we have a 0, or sorry, we have negative 10, then we have a 0. Remember, it has to be non-negative, so we're not worried about the negative numbers, even though it goes from negative 10 all the way to 0, then it goes to 1, then 2 is missing next, even though there's other numbers missing like 4, 5, and 7, and then 9, 10, 11, 12. Once again, we want the smallest or the minimum. In this case, that would be 2. So we return 2. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Y'all, solution is not that difficult. We should get through it fairly easily. So let's get into it. Now, the first thing we're going to do is we're going to create an array to count how many numbers fall into each remainder bucket. And there are their value possible remainders. So we're going to declare a variable called remainder. We're going to say colon. It's going to be an array of integers, and we're going to initialize it by saying equal. And then we're going to say array. Open under parentheses. We're going to say repeating colon 0, comma count colon value. Boom. Then we're going to come underneath that and we're going to iterate through all of the numbers in the input array. So we're going to come underneath this. We're going to say for num in nums. We're going to open up the brackets and we're going to compute a positive remainder. And so this is going to handle the negative numbers properly. So for example, -1 mod 4 plus 4 mod 4 would be equal to 3. But so let me show y'all. We're going to say let post remainder equal, open up the parentheses, num mod value plus value mod value. Boom. And then we're going to increment the count for that remainder bucket by coming underneath this, and we are going to say remainder, open up the square brackets, post remainder, come outside the square brackets, and we're going to say plus equals 1. Boom. Then we're going to come underneath this outside of the for loop, and we need to initialize tracking variables for the smallest remainder bucket. So we're going to say declare a variable called min idx. We're going to say colon int equals 0, comma min remainder colon n equals remainder square bracket 0. Boom. And now we're going to loop through all of the possible remainders to find the one with the smallest count by coming underneath this, and we're going to say for I in 1 dot dot less than value. We're going to open up the brackets, and if remainder square bracket I is less than remainder square bracket min idx, then we're going to come outside of this. We're going to open up the brackets, and we're going to update if a smaller frequency has been found by saying min idx. We're going to set that equal to I, and then we are going to say min remainder. We're going to set that equal to remainder square bracket I. Boom. Now the smallest integer that cannot be represented is given by the number of complete sets times the value plus the smallest remainder index. So we're just going to come right here, and we're going to say return min remainder times value plus min idx. Y'all, that should be all she wrote. Let's give it a run. Let's give it a run and see how it runs before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 1 millisecond beats 100% of users. That's what I'm talking about. That's what I like to see. So with that being said, y'all, make sure you get one more look at the code. Read it, learn it, love it. This is the top part. Or actually, yeah, this is the whole code right here, y'all. So yeah, read it, learn it, love it, and internalize it. Make sure you understand what's happening. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.